Hey y'all, me again. Well, here we are. This is super crazy awkward for me to do, but I'm gonna do it, and we're gonna love it. Man, this COVID-19 just unprecedented. So I loved you guys, prayers, and but I only have 15 minutes, so I gotta get on this screencast-o-matic, so I gotta get grooving. Okay, so nothing like hitting the ground running. Well, I was going to do a book walk of chapter 10 of Circles, and okay, we did it. Boom. Awesome. Okay, a lot to cover there, so much, but you know what? That is what it is. Basically, on that regards, really we need to know pi r squared, which is area of a circle, and we need to know circumference, which is 2 pi r. Not going to come into play today, but these two will be just fine for what we're going to have to do for the remainder of the year. Okay, area, perimeter, and volume. That's what we've got going on. So this chapter 11 is devoted to area and perimeter of many geometric the pretty much is most of the figures we've learned. We're going to do some more challenging ones like hexagons and octagons, etc. So let's start with the two easy ones: areas of triangles and parallelograms. Now remember, a rectangle is a parallelogram. So you've in your book you've got the picture there with the books leaning up. And it's a rectangle, and if you take a rectangle and you just turn it on the side a little bit, and you can see the books, the area is going to be the exact same. And so the formula for an area of a rectangle and the formula for the area for a parallelogram are the exact same. All right, so yay. Perimeter. Perimeter is a little bit different animal, because really perimeter is just adding up all the sides. So if you've got you already know the formula for perimeter of a rectangle. You know, you've got W and L and W and L, and really it's W plus L plus W plus L. But you know that can be simplified to 2W plus 2L, where L and W stand for length and width. Okay? So if you had a triangle, like say you had this triangle, you know, you had side 1, side 2, side 3, side 1, side 2, side, it's a little messy there. But this plus this plus this is the perimeter of that triangle. Now, if it were an equilateral triangle, you could come up with your own formula easily enough, and you could say that the perimeter of this equilateral triangle is 3 times S, whatever side length S is. Okay? So the formulas for perimeter are often dictated by the shape. I mean, you could have the shape of a house thing going on here, and you know, it's what? How do I get what's a formula for this? Well, there may not be a formula other than adding up the sides. Well, you can get these side lengths because it's part of a triangle. This is part of a rectangle. Often you may have to like draw a line like that to split it up into different parts. And this is actually much more useful for area, where you're splitting up it into parts. So let's dive into this. Speaking of height, so you've got a parallelogram here, all right? And in your formula, we're going to pretend that these are parallel for a moment. I'm trying to do this for speed's sake here. And your book has this as the height, okay? Well, you could also think of this as the height as well. Height has to be perpendicular, or not perpendicular, perpendicular, has to be 90 degrees. So this is h as well, if they gave you that out here. So it'd be from base here to this base here. That's height. Now, what if I wanted to turn this? I could turn my paper all the way around, and instead maybe I'll redraw it this way. So say this is this one, okay, and so if this were base 1 over here, and this were height 1 over here, the formula would be area equals base 1 multiplied by height 1. Well, take the same, pretend we're going to pretend for a moment that these guys are this exact same. Okay, I just turned it I took my paper and turned it the other way. Well, that would be a different base. This would be base 2 over here. All right, and let's say that's the height. That's a whole different other height. That's h2. So area would be b2 multiplied by h2. Totally fine. It just depends on your orientation of the problem. Okay, so if you have a triangle like this, let me get my fat hand out of the way here. If you have a triangle like this, all right, well, what's the height? Well, the height could be this. All right, that's height, and there's a base there. And the formula for a triangle is very similar to a parallelogram. I'm not going to go through the proof of it. It's pretty good proof, but it's 1/2 base times height. You probably already know this. Okay, well, what if I take the same triangle and just draw it a little bit differently? What if I want to draw it from this edge here being on the bottom? Okay, so we have to like take our thinking caps here a little bit, and I draw it from that edge. So I'm going to draw it. I'm going to flip it this way. I'm going to put the short side here, and then the longer side here, and the longest side on the bottom. So taking that same triangle, I kind of and reoriented it down here. Well, this is a different base. I'm going to base 2 subscript there. And this would be the height. Okay, remember height's 90 degrees. So it always depends on how your picture is oriented, what you can acquire, what angles you may have. You have to remember those trigonometric equations and whatnot. So we're going to dive into this further. I'm going to work a few problems, and let's get cracking, all right? Okay, so I want to find the area and perimeter of this figure that just appeared on your screen. Yay, because that's the magic of pause. Okay, so let's focus on perimeter first, okay? So perimeter, again, adding up all the sides. If you look at the shape here, I've got this, I've got this. This is the perimeter is always the outside edge. If I want to build a fence around something, it's the outside edge. So it'd be this, along here, along there, along there, along there, and along there. I want to build a fence, okay? So this is 35 and this is 35. So I can already put that down because I know that they're congruent. This is a parallelogram. The definition of page 515. This is this allows me to know that this is a parallelogram. Okay, if that's 25, that's 25. Okay, so 35. So I'd have 35 plus 25 plus 28. Okay, so I got this plus this plus this. All right, and I got a plus a 20 over there. So plus a 20. All right. So, but I got this guy that I don't know how to do. Uh-oh, yes I do. I sure do. Remember that both of these are both right triangles. And so I can set up the Pythagorean theorem. 20 for the hypotenuse squared equals 20 squared. And I'm going to call this x squared. And I'm going to call this y. And I'm going to set that one up, the other one up over here. Remember, opposite the hypotenuse here. So this one's going to be 35 squared equals 28 squared plus y squared. Okay? So I'm going to go ahead and solve that real quick and show the final product here. Hold on a second. Okay, so we have solving for x here. We have the square root of 225, subtracting this, and over here we have the square root of 441, each of which are both perfect squares. So 15 equals x, and y equals 21. I'm going to tack those into the end of here, and that equals my perimeter. Okay, so perimeter equals the sum of all those. All right, okay, adding all those together, we get 144, whatever the units were, whether feet, meters, whatever. Okay, so often in perimeter and problems like these, units will be provided. Okay, so now, that was area. We just had to remember how to use the Pythagorean theorem. Booyah. Now what about area? One thing I love about area is come up with your own little mini formula. Okay, so what I mean by that is area of this whole thing, okay, is going to be the area of triangle 1, I'm going to use subscript, plus area of the parallelogram, plus the area of triangle 2. Now, if you can do it all in one part, now this is a trapezoid, and we could use the formula for the area of a trapezoid, which you don't know yet. That's next time. Okay, so we can't use the formula for area of trapezoid yet, but this right now, this can be this plus that. Okay, if I want the area of this whole shaded region. Okay, let me show the setup for that real quick. Okay, I know this looks freaky scary right here, but focusing on this triangle right here, this is 1/2 base 1, so that'd be this base right here. times height 1, plus for the area of the parallelogram, it'd be base 2 times height 2. So base 2 multiplied by height 2, it actually turns out the height for the area 1 and or the triangle, these are the same. Okay, and then area of this one, this would be this base and this height. Now I could do it from here, but I have to do extra work if I wanted to find the height from here. Okay, so there we go. I'm going to go ahead and show you the work on that. Okay, so again, we've got the area of the first triangle plus the area of the parallelogram plus the area of the second triangle. Boom, boom, boom. If units were provided, you put that or put unit squared. All right, I'm going to try to get one more example squeezed in here. Okay, as we can see here, we've got a whole like craziness going on. I wanted the area of the shaded region. All right, and so of course we have a little flap here that we've got not part of the shaded region. Typical geometry problem. Awesome. All right, so we have to analyze the situation and go, what is going on here? Well, we have to break things down into smaller parts. And the way that works is, you know that you can find the area of a triangle. So I'm going to break this down and say I can find the area of this triangle here. I have 60 degrees here, I have 4. I'm going to have to use a tangent function here to find this opposite side. Taking oats away, opposite over adjacent. I can find this opposite side, which will also give me the height of this, I'm trying to look from here to there, and that's kind of fun, of this rectangle. So it's going to be area of, whoops, I didn't want that one, dadgummit. Okay, not that, but this big one. So this big one here, the area of this rectangle. So area of this triangle plus the area of the big rectangle, which will also be the height, which will give me that. So area of the left triangle, that's what that is, plus area of the rectangle minus, that's supposed to be right there, it's a little blurry, minus the area of this right triangle, not on the right, not a right triangle, but it's the triangle that's on the right. Okay, kind of confusing. So triangle A and triangle B maybe might be better. So triangle A plus big rectangle minus or subtract out that region will give me the area of what I want. Okay, so let me show you the setup for that. All right, so as we can see, the little boom, it shows up here. We got height. I use height instead of hypotenuse. Okay, this is opposite side. Opposite over adjacent equal opposite over adjacent. Solve for 8 height. Okay, if I put an x in there. All right, so that gives me 7 to be this approximately 6.9, but round to 7. Okay, area of the triangle there is 1/2 times 4 times 7, and then we've got that. All right. All right, so then we have the area of the rectangle. All right, we found the height here. And we know this. Wait, where'd that 11 come from? You see the 11 times 7? Well, 7 I know because that's that. Where'd that 11 come from? Well, if this whole thing is 15, then I subtract 15 minus 4. All right, wait a second. 8, 15, wait, where'd I get 11 from? Okay, wait a second. How'd that work? 15 minus that, that gets to be 11. Okay, simple math, easy. All right, so 11, that's 11. But then we have this last one, and I'm running out of time here. How do we get this last one? Well, we already know this. So from here, it's base times height. And I'm going to say that's the height there, because it'd be really difficult to figure that out. But I know that I can make that 90 degrees right there. Okay? So I already know that to be 7. How do we get this distance right here? Well, again, if I know all that's 15, I know that's 4, and I know that's 8, then this distance has to be 3. And so then 1/2 times 3 times 7, and then that's approximately 10.5. Okay, I'm gonna run out of time. I only got 15 minutes, and that about covers it for this first section. Looking forward to just keeping this. We're going to do maybe a Zoom at some point in the maybe next week, and but for right now we'll do instructional videos, and may God bless you.